speaker that we have today is Rahim here. He will talk about little things about how you could build a TriggerBot yourself. So let's welcome.
Thank you. Hi everyone.
Hello.
My name is Rahim and I'm an iOS engineer at YPad. And today I hope to teach you folks about reverse engineering and how to build a TriggerBot. So for anyone unfamiliar with first-person shooters, I'll go over a bit of terminology. This is a screenshot from Counter-Strike source. The crosshair is the thing at the center of the screen in the giant red box. And it's basically what our player is aiming at. And a TriggerBot is some software that we run, which will automatically fire when our crosshair is over an enemy. So a TriggerBot is just a loop. And we check if our crosshair is on an enemy, and we send a mouse event. Seems simple, right? Yep, it is. That's all, folks. Thanks for listening. Just kidding. But before I get into why it's not so simple, I want to talk a bit about reverse engineering. To me, reverse engineering is simply another word for seeking understanding. We want to understand how things were built and why they were built that way. We want to use the information that we have, clues, to extrapolate design. For building a TriggerBot, we need to reverse engineer the game. We need to understand how things were built so that we can find what we're looking for. Okay, but where do I begin? Science. We start with science. And what I mean by that is the scientific process that was drilled into all our minds since we were young Padawans. So let's go ahead and do it. So first we need to ask ourselves, what information do we need to build a TriggerBot? And there's really only one question that we have to answer in order to build a TriggerBot, which is our crosshair pointing at an enemy? There's 3 keywords in that question, which are all separate entities that we need to find. We need to find our crosshair, we need to find the value it is pointing to, and we need to have some kind of list of enemies that we can check it against. Right, now here comes the fun stuff. We need to identify the clues that are already available to us so that we can use this information later. Every game is different, but let's take Counter-Strike for example. We've got a whole bunch of information available to us. We've got health, money, armor, team, a whole bunch of stuff. Okay, so that's great. Now what? Now we put ourselves into the shoes of the game developer. If I was the developer, I would probably have a player object containing ID, health, team, stuff like that. And I would probably have an array of players somewheres so that I can easily access all the players. For example, if I had a scoreboard somewhere. So if this player list exists, and if we can find it, then we're pretty much set to build our TriggerBot. Okay, seems good. Let's go ahead and test our hypothesis. Here's where we bring out the tools. We can use almost any debugger. I like OllyDebug and CE. And we're going to use these tools to scan and sort through memory. The first thing that we want to do is we want to actually run the game and attach the debugger to the client.dll. That's where all of the information that we care about is actually stored. And we can use OllyDebug to get a dump of all the string references. And then what we want to do is we want to search the values that we already know about. For instance, health. It might be a little hard to see in this screenshot, but it shows the string m_iHealth, and next to it is push 90. This tells us that the health is stored 90 bytes away from the base of the player object. And we can do the same thing for team and other variables that we care about. And here we can see that the team is stored 98 bytes from the base of the player object. So why do we actually care about these values? Well, it gives us a vital piece of information. Now we know that if we find a health address with a team number that is 8 bytes in front, then we have found the address for a player in memory. But if we find a health address without this team number that is 8 bytes in front, then it's some garbage address that we really don't care about. Well, now we can begin our search for the fabled player list. Just a quick reminder of where we're at. We've ran the game, and we've attached a debugger. We need some kind of strategy to find the player list if it does exist. So why don't we start by finding our own player? So we can see that we have 100 health. So let's scan client.dll for all memory addresses containing the value 100. Then we can manually inspect each one of them to see if there's a team value 8 bytes in front. 6,000 results. Yay. Luckily, we can continue to filter down this list. We can resume the game, have our player take some damage, pause, and search for the new health value. And we can keep repeating this until we have a much more manageable list. Now, it's safe to assume that all of these values are our player's health, but only one is from the player object. The other values are probably used in, for example, UI elements, or maybe variables in some kind of calculations. We can find the address of our player object by manually inspecting each of these addresses using our clue that the team number is 8 bytes ahead. Then we take the address that meets this requirement and subtract 90 bytes to get the base address of our player. We can repeat this process with our player object to find that there is in fact a list of players. And actually, we can find that there's a list of all entities in the game. And once we have this value, it's going to be just a static pointer that will not change between game instances. But it could change, for example, when the game is updated, and then we would have to go through all of this again. So right now we have what we need to build a TriggerBot. The simplest TriggerBot will look something like this. But we're way too cool for that. Let's sprinkle in some things that'll separate the pros from the noobs. I'll start with the loop. It's common to use this loop in any kind of event loop to prevent destroying your CPU. But since this is a TriggerBot, we actually only need to loop at the frame rate of our monitor. So if you have a 144 Hz monitor, you only need to loop 144 times per second. And in each cycle, we're checking if the value of our crosshair is pointing to an enemy player ID. By the way, I forgot to mention this, but in Counter-Strike, the crosshair ID is actually a member variable of player, and it points to an entity ID. Now, Windows has many APIs for reading memory, so we can just use these to check the values. When the check is true, we could do something as simple as sending a mouse down event. But there's actually two special tricks that I know that separates good TriggerBots from bad ones. The first trick is we want to simulate human variance. And this can be as easy as sleeping for a random time between 40 and 80 milliseconds. But it makes a huge difference in foiling cheat detection. The second trick is that we will not forget about mouse up events, and that we will not forget about having variance between mouse down and mouse up events. One very easy way to detect a TriggerBot is to check for the lack of mouse up events. And of course, it's suspicious when the mouse down and mouse up are less than 1 millisecond apart. I don't think any human can click that fast. Yay, we learned about all these stuff and things. Awesome. But there's really only two takeaways that I want y'all to take. The first one is that reverse engineering is about putting yourself in the developer's shoes. And most importantly, anyone can do it, so don't be afraid to try. Thanks.